Yeah, I can show like, oh yeah, I just refreshed that node. My bad, sorry. Mm, okay, this is one of your guys' iDRAC, right? This is the iDRAC that we used last time.
Yes.
I'm trying to use it for the demo purpose. Or I can use one on my system. Oh, this is the same one, right? Where's my ILO? 6175.135. One 36, 135. Okay. Um, let's look it over here. So this is one of the HP servers that I have. So if I go to system information and click on the processor, what I get is total of 32 cores, but I get 64 threads. So if you see in here, it is showing total of 32 cores, 16 cores per socket. So that's what it shows in here, 16/32. I have two processor 1 and processor 2, but I have only 16 physical cores in each. But with hyper multi-threading, what we did, we just increased its capacity into 2 threads. That's why we are getting 464 CPUs. So when we split it this way, the NUMA technology enables NUMA's non-uniform memory access. So instead of having one entry, the NUMA actually splits multiple entry with that particular section. Even for memory allocation, it knows which CPU can access which section. It splits it that way, the total memory. Say for example, here I have a memory. What is the memory information that I have? 256 gig. So if you see in here, the 256 would exactly be split between these CPUs to get access to it. even further down, which one should I use to show you guys? Do I have some? I don't have a server with me right now. Okay. So not only this section, I just want to show you guys this part. If you see this section, right? So you saw the DRM, how it's been split between the processor and the CPU would split by NUMA. Not only this section, even the IO devices or any other PCA devices, it knows which NUMA to it gets assigned to. Confusing, right? Say for example, CD. So technically, if you see, this is one of the interfaces that we have. ENS10F0. We have four interfaces in here. 10F0, 10F1, F1N P1, 0N P0. So we have four interfaces. This way you see it. Um, So these are those four Ethernet ports. Two of them were Broadcom. The other two of them is Mellanox driver. So even within this four um, nodes, the NUMA will assign which node it should exist on. So the technically this node ENS10F0, it's residing under NUMA node 0. So any activity, any operation that goes within this particular Ethernet interface, it goes to NUMA 0 uh, CPUs. Technically 0 to 47, 0 to 15, 32 to 47. Only these section it would go there for any process. It won't go to node 1 CPUs. So even the IO device, NUMA splits and assigns equally. So which means you have multiple path for any end-to-end operation, not just particular operation. In between functional scope, this is technically from end-to-end operation, how it can assign to improve the performance. So that you don't need to be in a big queue to get your things processed, waiting for more time. Bit confusing or bit aligned or bit
Why there are only two here, a node 0 and node 1? Why only two? It,
uh,
is it can
because it's two core processor, right? Node 0 and node 1. But here instead of 16, 0 to 15 itself, your 16 CPUs, right?
yeah
16
like
cores.
uh,
But we have
yeah.
split it into 16. This is where we have enabled only hyper threading. This is Intel server, right? Wait, let me check one more time.
Yeah, it is interesting.
It's Intel, right? But if you want to have split even the NUMA nodes shared across the processor, that still you can do. What you should be doing it. Oh, I need to reboot the node. It's going to take some time, guys. So if you guys have some minute.
Is there a limit on the number of code that can be assigned to a NUMA node?
There is no limit with respect to NUMA, but there is a limit with number of processor it's available already. Say for example, this is just a 16 core. If we have like 64 cores, we can go up to 128 vCPUs, not more than that.
Okay, so it's a 64 core processor, and how many NUMA nodes will we having? Four, or like can you have it like two or something like that?
Okay. NUMA node, we can have multiple. We can have 0 to 7, 0 to 8, all those things. But the CPUs, number of CPUs, it's been restricted. For example, over here, oh, I did a reboot. Okay, let me explain it here. See, node 0 CPUs, we have 0 to 47. Node 1, we have 16 to um, technically 31 and 48 to 63. I can split this one even more. Node 0, node 1, node 2, node 3. Node 0, I can have 0 to 15. Node 2, I can have 32 to 47. Like that, I can split. But this number of cores, there is a limit. We cannot expand more than 64. We can do 128, but the node distance, if you see in here, this would increase. If this distance has increased, then the bus interval to reach from not from even DRAM, from IO devices all the way to ALU, uh, it would be in a higher distance. Say, for example, the latency that we discussed before, that would increase. So that won't be performant efficient in a way. F9.
Are the node 1 and node 0 share some memory?
No, they don't share the memory. This is the total memory, 256 gig, that's been splitted equally between the processor. It depends on where you place your memory stick. That is the bus connects to your core.
Okay, are they communicate between, like if requires any input from another node, and how they communicate each nodes?
You mean between the CPU?
Yeah.
Well, it depends on the process how they accessing. So that's the reason we have the cores closer to it. We have bus connected between the CPUs to have those access. It would be more miniature, but I can show you guys with an example. Which one? I think for one of our Milan server, we have a architectural diagram. We will show, but those are for logical understanding only. Physically, I don't think we can show how it's going to go.
Sir,
Uh, so so this is a 32 core processor, right? So it's allocating the those threads, right, according to the nodes at NUMA node.
Mhm. Technically, this is two 16 core processor.
Yes.
Mhm.
So 16 core, that's 32 process, like 32 cores. So here, every node has 32. the thing. Is it threads that's allocating to a node?
Yes, that is
Okay.
the thread it is allocating. Let me have, where is my pinning? Okay. Okay, so you will get to this part though, but don't get too confused. So node 0, socket 0, node 1, socket 1. The socket 0 defines the core first processor. Socket 1 defines the second processor. These are the vCPUs. Technically, the zeroth vCPU pair is 32. The one CPU's pair is 33. So this is the original physical core IDs. These are the paired replicated ID on the right side. For this calculation, I'll go over with you guys in another meeting. But this is how the pair works. You need to understand which pair you need to have. For example, you are creating a virtual machines in the hypervisor, and you would like to provide the virtual machine to have same level of access between two sockets. Core 1 and core 2, you want to have equally shared. Say, for example, you are creating 4 vCPUs virtual machine, right? If we create all the 4 vCPUs in core 0, when core 0 get busted out, the VM eventually bust out. In one hypervisor, you might have like 10, 12 virtual machines. So for performance wise, we don't do it that way. What we do, if we want 4 vCPUs, we will assign 2 of them in one socket and 2 of them in the other socket. So in case either one of the socket get busted out, we can still have 50% of traffic running without latency. So that's how we define. So for that one, you need to know which pair that you are defining it over in here. So that's the reason all the node 0, socket 0, 0, 32 would be a pair. 1, 33 would be a pair. That's what we have mentioned in here. So between these processes, it knows how to connect because it knows it's replicated IDs that it trying to having more threads on. Does that answer your question, or did I understood your question in a different way?
Yeah, understood it. And if there are more than two nodes, like if there are two sockets and more than two sockets and there are more than two nodes, how will it allocate, like pair the cores?
Oh, you're saying we have only two sockets, but we have more than two nodes.
Two
Is
nodes,
that
yes,
what you?
yes,
Okay, that's the one I'm trying to show. So what it does, same way here, I told this for the core 0, it knows what its replicated ID, right?
yes,
Same way here, node 0, if we have node 0 is a primary, the physical one, it knows its replicated ID. So all those specific functions going over the ID pointed to the socket 0 CPUs and related memories. I'll show you an example over here. I need to disable a couple of things and enable a couple of things. If functioning. F9. Sorry guys for taking too much time. I know this is pretty bit uh, confusing, but you keep on working on it, you will get to know the details. The problem I couldn't show end-to-end operation because the mlog, the memory allocation and other things, it's more dynamic. We won't have a ball to track in a, we cannot do reverse engineering. That's issue that we have. I don't have a tool to show you guys.
So,
Mhm.
yeah. So, like, in one CCD, we have 8 cores, right? So, and one CCD would be assigned to one memory container. So, you're saying here is two nodes, like if dual sockets or two different nodes. So, the
Mm.
two memory containers are isolated from each other. So, what you mean is like the NUMA process would help to connect this container with the other node container. So, that's what you meant.
No,
Because no.
no,
Okay.
it won't connect it that way. It splits the within the container, it splits the function. In logically, it shows that is another multiple container. Technically, NUMA splits a lot instead of trying to connect across the bridges. What you're
So you mean there's a
see.
common memory and then it divides into various sections and that's how they connect the
Yes.
different cores.
So technically, whatever the slot PCA bus, the memory slots allocated to one socket, it would stay in same socket. But in the same socket, it splits more, and it visually shows this is not one socket. It's I'm splitting logically this one socket into three more sockets, four more sockets, something like that.
So, but in
So
the
it splits
physical,
a lot.
yeah, in the physical architecture, we see that they have they have eight different memory channels with eight different memory containers, right? So, what does that mean exactly?
Yeah, the four channels point to one side of things. The other four points to another side of things.
Yes,
If
yes.
we can't, I'm sorry.
No, no, nothing.
Uh, So if we can't equally split on those things, that's when you are overpowering one of the processor or underpowering another side of the processor. I think I have a diagram. South bridge, bridge, bus. Everything is a pictorial version. So this is what you are asking, right? This is one core over here, uh, but we have multiple slots of DRAM. I need a two socket system. I see. Yeah, here. So this is a technically a two socket system, right?
Yeah.
So you have over here 3, 6, sorry, 6, 12. 12 belongs to one processor, another 12 belongs to another processor. You cannot connect all the 12 over here and then say, hey, processor 2, go access this memory. It won't show. It's not the way it sees. What NUMA does, in this 12 processor, it splits 6 memory channel, and the core it creates number of threads. It splits and it shows, hey, I'm not just one processor. I'm a dual cloned version, so I have two way of it, so you can access sectionally and make it even faster. Again, it's same way. NUMA technically opens number of entry and exit points. So all the processing happens everything parallelly, and eventually we attain the deadline. That's when the throughput is hitting higher.
So then you have mentioned that there's a pair of nodes, right? From node 0, there's core 1, and from node 2, core 32, right? So they are the pairs. So in that case,
Oh, it's
what?
not in node 32.
No, I mean core 32 from
No,
node
this
1.
32 still belongs to node 0, socket
Okay,
0.
okay, okay.
So, oh, where it is. So if you see in here node 0 CPUs, you will see 0 to 15 one section, then it starts with 32. 32 is technically a replicated pair of zeros. No, only node 1 has 16 to 31 and then 48 to 63. That section is over here. It's not between the sockets, it's within the node. Within the node, it splits one core into two threads. one physical core into through two threads. So it knows which one is master and the other which one is a replicated thread.
Okay.
What we call PMD. It's not happening between the socket, it's within the socket. Even NUMA, if we go on the node level, if we enable it, it still splits within the socket. It won't go to socket 2. I mean, it won't share between these two. It still splits within the socket.
Oh,
That's the
okay.
reason we need to be very careful. We need to know where we place our PCI devices most precisely. Say, for example, the Ethernet interfaces or any server storage interfaces where we connect. Either it should be equally shared to avoid complication, or if it is mapped into one socket, one NUMA node, we need to make sure all the process goes from one NUMA node. If we connect our Ethernet interface to one NUMA node and we are having our application in another NUMA node, which is not belong to the same socket, and we request all the transaction to go out through this network interface card, there will be a tremendous delay because like you mentioned before over here, where is this? Okay. So instead of going between this one line, what it does between the socket, it needs to go to all the way up and it crosses between the core, and from there you need to come over here. So technically it will not use the same bus path. It uses multiple bus path, thus create a lot of latencies. Although the operation performance would be similar to what you have in the same socket thing, because it's between the CPUs, it can reach faster. It's closest to each other between the cores, but once it gets outside of the core, then it creates another path to reach to get out of that particular name. So that is one of the customer issue we faced. They had their application running on one NUMA node, but technically our interfaces on the first core 0 NUMA node. So they were keep saying we are not reaching the desired throughput. I hope I'm not losing this traction. Okay. So these settings, the NUMA settings, technically we should be doing it in BIOS. BIOS is where important from now on in our life. So I'm going into BIOS RBSU platform configuration. I've chosen custom workload profile, reason being the virtualization option I've enabled VTX. This is okay. So I've enabled in here hyperthreading, right? Can choose disabled in here. What I get only um, 16 core, which is only 32 core. I can disable it in here. But over here, okay, I think let's go on to another option. Memory. So I've enabled NUMA over here. So I've enabled hyperthreading before. So using that hyperthreading per physical core, it is started populating. I can handle two threads. So I'm just turning into from one physical core to two virtual cores. But if I do this virtual NUMA enabled, This is a new one on the memory option, virtual NUMA enabled. So that particular spec technically splits the socket itself into multiple NUMA nodes. So per socket, we calculate one NUMA when we enable just NUMA. But right now, the virtual NUMA itself, we are splitting into another virtual NUMA, which again create another NUMA node within the system. I'll show you guys the difference. The old one I was showing something like this. I have enabled hyperthread, which eventually splits the number of CPUs. But now I've enabled virtual NUMA, which eventually splits number of nodes itself. Uh, we cannot enable both because it's a performance hit. Uh, it's like a spaghetti. If you enable both, the bus calculation and it reaches, time to switch between the cores and to reaches its spot takes a lot of time. That consumes a lot of memory. Okay, till this gets booted, that does anyone have any questions? I'll try to find out a tool to show you guys even in depth the reason why we are going for NUMA that requires malloc specs as well.
In a two socket system, can we do three NUMA nodes with equal resource sharing?
We cannot do three NUMA nodes. Technically, it's a multiple of two. So with two socket system, we can do 4 NUMA nodes, 8 NUMA nodes.
Yeah, got it.
So first one socket we can split into 4. The other one we can split into 4. Technically, we can have 8 NUMA nodes.
Can
8
we
splits.
split two in one socket and in another socket 4?
No, it won't work that way because the BIOS is a common for both the processor.
Nodes
Right
must
now we don't
nodes,
have that functionality, but that's a good one, more modular one. We might get sometime later.
nodes must be equal for a socket of both the sockets.
Yeah, that's how the bus split also will be taken care of. It's gonna take more time. So I think for your system, does anyone have login access for this one? Can you guys log in and share?
Yes.
Because the one I'm seeing in here, the configuration on the system side. Oh, 7B12. This is Epic processor. AMD V virtualization. Oh, it doesn't have SMT, I believe.